Raman spectroscopy is known as a molecular fingerprinting technique, so it's very useful for identifying different species in a complex mixture. Lab Services recently wrote a proposal to do a test where we're going to use Raman spectroscopy to investigate different molecules in a cell culture media. These molecules are very common ones like glucose, lactose, ammonium, citrate, so just kind of very common things that we're going to explore in the cell culture media. And we're going to use Raman spectroscopy because we will get very distinct signatures from each of these components, and once they're in a mixture, we should be able to identify each component. So spectroscopy is good for this application because the customer desires a certain concentration range, and they have certain limits, like a low end, a high end, and they desire a certain limit of detection. So with this technique, we're going to explore a wide range of concentrations for all of these different analytes. Using spectroscopy, we can quantify that. So we can look at the intensity of the peaks in the Raman spectrum and correlate that to the concentration of the analyte of interest. And also, like I just mentioned, getting those unique fingerprints of each species in the complex cell culture media, we can look at that with using spectroscopy. I'm looking forward to measuring this because I haven't really worked with cell culture media before, and so I'm interested to see what that signal will look like. I'm very curious about that because it's a complex matrix. It's going to be a very rich, it's going to give a very rich spectrum.